Stop believing the fairy tale that the steam locomotive died peacefully in its sleep. It didn't fade away because of nostalgia, and it wasn't gently retired by the natural progression of time. Steam was murdered, and the weapon wasn't just diesel technology in the abstract. It was one specific machine, built in secret in 1939, that was so lethal to the old world order that it terrified railroad executives and defied the laws of physics as they understood them. This single set of units possessed the power to bankrupt the coal industry and dismantle a century of infrastructure overnight. But just as it was about to strangle the steam industry in its crib, the United States government stepped in and effectively banned it. They didn't just stop the revolution. They forced a dying technology back onto the rails by federal decree, creating a zombie era of steam that never should have existed. You have been told that World War II accelerated technology, but in the case of the American Railroad, the government actively suppressed the future to salvage the past. You're watching rust and thunder, excavating the machine's history buried. If you value this depth of mechanical archaeology, subscribing ensures you don't miss the next investigation. To understand why the federal government would eventually intervene to stop a locomotive, we first have to stand on the ballast of 1939 and look at the titan that was about to fall. The steam locomotive was not just a machine. It was the industrial heartbeat of the continent. For 100 years, the reciprocating steam engine had been the undisputed king of overland transport. By the late 1930s, this technology had reached its absolute zenith. We are talking about superpower steam massive, articulated behemoths like the Union Pacific Challengers and the Norfolk and Western Class A's. These were engineering marvels of forged steel and brute force, capable of dragging mile-long coal drags over mountain ranges. They were magnificent, loud, and visually terrifying, but they were also fatally flawed. The dirty secret of the steam era was that a steam locomotive was a financial disaster waiting to happen. They beat the track to pieces with their unbalanced driving wheels. They required an army of specialized labor to maintain: boilermakers, pipe fitters, hostlers, and firemen. They had to stop constantly for fuel and water, requiring a vast, expensive network of coaling towers and water tanks every 100 miles. A steam locomotive spent more time in the shop being repaired than it did on the road earning revenue. In the corporate boardrooms of New York and Chicago, railroad presidents knew they were bleeding cash, but they were trapped in a technological Stockholm syndrome. They couldn't imagine a railroad without steam because steam was the railroad. Enter General Motors. In the late 1930s, GM was not a railroad company. They were an automotive giant, an outsider with no respect for the sacred traditions of the Iron Horse. They looked at the railroad industry and didn't see romance. They saw inefficiency. They saw a market ripe for a hostile takeover. Through their subsidiary, the Electro-Motive Corporation, or EMC, they had already toyed with streamliners, flashy, lightweight passenger trains that looked good in newsreels but couldn't pull a heavy freight train to save their lives. The steam builders, Baldwin, Lima, and ALCO, laughed at them. They called EMC's internal combustion engines toys. They insisted that no diesel engine could ever match the starting tractive effort of a steam locomotive. You could not replace a heavy 284 Berkshire with a glorified truck engine. It was physics. It was impossible. GM didn't argue. They just went into the lab and built a monster. The project was designated the FT. The F stood for freight, and the T stood for 2,700 horsepower. But the numbers didn't matter as much as the philosophy. This wasn't a locomotive designed by railroad men. It was a locomotive designed by automotive engineers who treated a train like a production line component. They took a 16-cylinder, two-stroke diesel engine, the legendary 567 prime mover, and standardized it. They realized that one diesel unit wasn't enough to kill steam, so they lashed 4 of them together. An A unit with a cab, a B unit booster, another B unit, and another A unit. 4 sections permanently coupled with a drawbar, acting as a single 4-unit machine generating 5,400 horsepower. This was the EMC demonstrator number 103, and when it rolled out of the LaGrange, Illinois plant in late 1939, it didn't look like a train. It looked like a weapon system. It was sleek, bulldog-nosed, and painted in a dark green and yellow scheme that screamed modernity. There was no smoke, There was no reciprocating hammer blow on the rails, just a low, constant thrum of electric traction motors and the whine of the roots blowers. General Motors knew that the railroad industry was an old boys' club that resisted change with religious fervor. They knew that simply publishing the specs wouldn't work. They had to humiliate the steam locomotive in public. So, in November 1939, they launched the boldest marketing campaign in industrial history. They sent number 103 on an 83,000-mile tour across 20 different railroads in 35 states. The mission was simple: find the hardest, steepest, most steam-dominated routes in America and destroy the competition. The results were not just good. They were devastating. On the Rio Grande, in the thin air of the Rockies where steam engines gasped for oxygen, the 103 didn't even break a sweat. It utilized dynamic braking, reversing the electric motors to act as generators, to slide heavy freight trains down mountain grades without using the air brakes, saving the railroad millions in will wear. On the Santa Fe, it pulled loads that would have required 2 or 3 steam engines and did it without stopping for water. The data coming back to EMC headquarters was staggering. The 103 was operating at half the fuel cost of steam. It required almost no maintenance between runs. While a steam engine needed to be cooled down, washed out, and rebuilt after a long run, the 103 could arrive at a terminal, refuel, change crews, and turn right back around. It was a machine that didn't need to sleep. Railroad presidents who had sworn loyalty to coal began to panic. They saw the numbers. They realized that if they didn't switch to this new machine, their competitors would, and they would be driven out of business. Orders began to flood in. The Santa Fe, the Great Northern, the Southern Railway, they all wanted the FT. The death warrant for steam had been signed. The factories in La Grange were spooling up to flood the continent with diesel-electric power. The revolution was supposed to be swift, brutal, and total. By 1941, it looked like the steam locomotive would be extinct within 5 years. But history had other plans. Across the oceans, the world was catching fire. The conflict in Europe and the rising tension in the Pacific were shifting the American economy from a depression recovery into a war footing. The United States government established the War Production Board, or WPB, an agency with absolute dictatorial power over American industry. Their job was to allocate scarce materials, copper, steel, aluminum, and oil, to ensure the survival of the Allied forces. And here lies the great irony of the diesel revolution. The very thing that made the diesel locomotive superior, its precision engineering, its heavy use of copper for electric traction motors, and its reliance on refined oil, made it a liability in the eyes of the War Production Board. Copper was needed for shell casings and field communications. Precision machining capacity was needed for aircraft engines and submarine diesels. Steam locomotives, for all their inefficiency, were crude beasts. They were built from boilerplate steel and cast iron, materials that were relatively abundant. They burned coal, which the US had in nearly infinite supply. They were low-tech heavy metal. As 1941 turned to 1942, the WPB looked at the railroad industry. They saw a transportation network that was about to be pushed to the breaking point by troop movements and war material transport. They needed motive power, and they needed it now. But they didn't care about efficiency. They didn't care about the long-term operating costs of the railroads. They cared about saving copper and oil for the Navy. So the order came down. It was a bureaucratic stranglehold that would warp the trajectory of railroad history. General Motors was told to halt. The revolution was paused. The government effectively said, "You cannot build the future. You must build the past." This is where the story shifts from a tale of technological triumph to one of industrial frustration and buried prototypes. The FT, the machine that had proven it could save the railroads from bankruptcy, was placed in a regulatory cage. But the details of this restriction, and the specific, bizarre ways the government forced railroads to buy locomotives they didn't want, reveal a chapter of history that most textbooks gloss over. To understand the true failure here, we have to look at the blind spot of the War Production Board and how their decision to freeze technology created a chaotic, desperate scramble for power that birthed some of the strangest, most doomed locomotives ever to touch the rails. This wasn't just a logistical oversight. It was industrial sabotage authorized by federal decree. You have been told that American industry during World War II was a perfectly oiled machine of efficiency, a united front where the best technology rose to the top to defeat tyranny. That is a lie. In the railway sector, the War Production Board didn't prioritize performance. They prioritized paralysis. They looked at the Electro-Motive FT, the only weapon capable of solving the nation's critical transport bottleneck, and they didn't ramp up its production. They strangled it. They took the most advanced piece of heavy machinery in the world and subordinated it to a quota system that prioritized the quantity of steel over the capability of the engine. The logic employed by the board was cold, calculated, and devastatingly short-sighted. It was codified as Limitation Order L-97. This was the document that effectively froze time. The government argued that diesel engines required copper for their generators and traction motors, and high-grade alloys for their crankshafts, materials that were desperately needed for the Navy's submarine fleet and the Air Corps' bombers. Steam engines, by contrast, were built from low-tech iron and steel. They were heavy, inefficient, and water-thirsty, but their materials were abundant. Consequently, the government commanded a resurrection of obsolete technology on a scale that defies industrial logic. Railroads that were begging for the FT, pleading for the diesel efficiency that could haul twice the tonnage for half the cost, were flatly denied. Instead, they were force-fed new steam locomotives they didn't want and couldn't afford to maintain. It created a bizarre zombie economy on the rails. You had the Lima Locomotive Works, a titan of the steam era, churning out massive, beautiful Doom 284 Berkshires and 484 Northerns. These were engineering marvels of the 19th century philosophy, polished and perfected, yet they were being built in 1943 for a world that had already moved on. These engines were born dead. The railroads knew that the moment the peace treaties were signed, these brand new steam giants would be lined up for the scrapper's torch. It was a colossal waste of capital and labor, justified only by the terrifying math of total war. But the damage of Limitation Order L-97 went deeper than just forcing the production of unwanted steam. It shattered the competitive balance of the diesel market itself in a way that would haunt the industry for decades. The board decided, in their infinite bureaucratic wisdom, to compartmentalize the manufacturers. Since General Motors' EMD division was the only one with a proven road freight diesel, the FT, they were assigned the exclusive right to build road freight diesels. It sounds like a victory for EMD, but it was a double-edged sword. While they were allowed to build the FT, they were forbidden from building switchers. Conversely, the American Locomotive Company, ALCO, and Baldwin were legally barred from building road freight units. They were pigeonholed into building switchers and road switchers, or forced to continue their legacy steam production. This artificial segregation of the market meant that ALCO and Baldwin were denied the critical operational experience of running heavy-haul diesels on the main line during the most intense traffic period in human history. While EMD's FTs were out there racking up millions of miles, exposing their flaws, proving their reliability, and gathering priceless data on long-haul performance, the competitors were stuck in the rail yards, building low-speed shunting engines. The government had inadvertently handed EMD a monopoly on experience. If digging into these forgotten layers of industrial history reveals how complex the past truly is, your support helps us keep these archives open. The consequences of this regulatory cage on the tracks were immediate and chaotic. Railroads, desperate for any motive power to move troops and tanks, began operating Frankenstein fleets. A single depot might have to maintain 50-year-old steam engines dragged out of retirement, brand new unwanted steam behemoths, a handful of prohibited but acquired experimental diesels, and the precious few FTs they could get their hands on. The logistical strain was immense. Steam engines required water stops every few hours, roundhouses for maintenance, and armies of boilermakers. The FTs just needed fuel and a crew change. The contrast was humiliatingly stark. Every day a railroad executive looked out his office window. He saw the future being held back by a government order. Furthermore, the freeze on design innovation meant that flaws were locked in. The blind spot of the War Production Board was the assumption that a locomotive is just a unit of pulling power, interchangeable with any other. They failed to understand that the FT wasn't just a replacement. It was a revolution in logistics. By capping the production of FTs, they forced railroads to run shorter trains, move slower, and clog the main lines with steam engines that couldn't handle the grades without helpers. The bottleneck at the mountain passes wasn't due to a lack of tracks. It was due to a lack of torque that the FT had and the steam engines lacked at low speeds. The situation became even more surreal when the government, realizing the desperation of the motive power shortage, began pushing the other manufacturers to rush their own road diesels into production toward the end of the restriction period, but without the necessary testing time. This is where the true failures of the era began to germinate. ALCO and Baldwin, terrified of being left behind by EMD's government-sanctioned head start, rushed their post-war designs. They were trying to leapfrog a technology gap that the war had artificially widened. They began drafting plans for locomotives that looked like the FT on the outside but lacked the robust, battle-tested internals that EMD had perfected under the pressure of wartime freight hauling. This created a pressure cooker of engineering compromises. To meet the government's tonnage demands, manufacturers started cutting corners on non-essential components, using inferior cabling, or rushing the casting of engine blocks. The blind spot had created a market where simply existing was enough to get a sale. Quality control slipped because the railroads would buy anything that could move. This era of desperation birthed machines that were temperamental, prone to electrical fires, and structurally suspect. They were the direct result of a command economy trying to micromanage a technological transition it didn't understand. The FT, meanwhile, became a legend in real time. The crews operating them treated them like royalty. In a sea of soot-choked steam tunnels and failing experimental prototypes, the FT was the only machine that did exactly what the brochure promised. It didn't just pull freight. It pulled the entire perception of diesel power out of the realm of novelty and into the realm of necessity. The WPB's restrictions, designed to save resources, had the ironic effect of proving EMD's superiority beyond any shadow of a doubt. By limiting the supply, they drove the demand into the stratosphere. Every railroad president who was denied an FT in 1943 vowed that the moment the war ended, they would scrap every steam engine they owned and buy nothing but General Motors diesels. The stage was set for a post-war massacre. The government had frozen the timeline, but the pressure building behind the dam was immense. The steam giants were building their own coffins with every new locomotive they delivered. The competitors were scrambling to build untested rivals. And the FT sat in the middle of it all, a caged predator waiting for the gate to open. But as the war drew to a close, a new threat emerged, not from the government, but from the sheer arrogance of the diesel manufacturers themselves, who believed the war had been won, not realizing the mechanical betrayals that were about to surface in the peacetime rush. Because here is the brutal reality the history books often gloss over. Victory is the most dangerous moment for any machine. You might assume that once the War Production Board lifted its iron grip, the EMD FT simply rolled out onto the tracks and claimed its crown without a fight. That is a lie. The peacetime rush didn't bring order. It brought industrial chaos, a frantic, blood-in-the-water scramble where engineering integrity was sacrificed on the altar of speed. The government had stepped out of the way, only to be replaced by a far more volatile force, the desperate, unchecked greed of a market starving for modernization. General Motors had proven the concept, but in doing so, they had painted a target on their own back. Every other builder, Alco, Baldwin, Lima, woke up to a nightmare scenario where their century of steam dominance had evaporated overnight. Their reaction was not calculated innovation. It was panic, and panic builds terrible locomotives. While the FT had spent the war years proving itself on the torturous Santa Fe grades, the competitors began throwing prototypes together with reckless abandon, trying to bypass the years of R&D that EMD had locked down. This is where the story turns from a triumph of engineering into a graveyard of failed ambitions. The mechanical betrayals weren't just about broken pistons or cracked frames. They were about the betrayal of the railroad tradition itself. Companies that had built the leviathans of the steam age suddenly tried to shove diesel prime movers into chassis that weren't designed for them, creating Frankenstein monsters that looked impressive on paper but tore themselves apart on the rails. Consider the landscape of 1946. The FT was no longer the experimental upstart. It was the standard, but it was an imperfect standard. The very design that made it a predator, that semi-permanent drawbar connecting the A and B units, became a logistical headache for maintenance crews who wanted flexibility, not a rigid, inseparable block of power. The railroads loved the torque, but they hated the shop time. EMD knew this. They knew the FT was just the battering ram used to break down the door, and that the real conquest would require a machine that fixed these fatal rigidities. This transition period is where the true rust and thunder reality sets in. It wasn't a clean swap of steam for diesel. It was a messy, oily war of attrition. You had brand new diesels from Baldwin, the infamous centipedes, that were so complex and unreliable they required a team of specialists just to keep them running, while next to them, 50-year-old steam engines were still hauling the tonnage because the modern replacements kept failing. The irony was palpable. The industry had decided steam was dead, but the new diesels were struggling to bury the body. If uncovering these specific mechanical disasters, the locomotives that promised the future but delivered only scrap metal, is the kind of deep-dive engineering history you value, a like on this video helps signal that we should open more of these forgotten files. The FT, for all its wartime glory, was quickly becoming obsolete by its own hand. EMD didn't rest. They took the bleeding-edge data from those millions of wartime miles and immediately began cannibalizing the FT design to build the F3 and eventually the F7. This was the genius of their strategy that the government had inadvertently aided. By freezing the competition during the war, the government gave EMD a monopoly on experience. While Baldwin and Alco were guessing, EMD was iterating. They were refining the 567 engine block, tweaking the traction motors, and solving the electrical gremlins that plagued early diesel electrics. But there is a darker chapter to this dominance, one that circles back to the government's interference. As the FTs and their successors flooded the rails, wiping out the big boys and the challengers with ruthless efficiency, the sheer scale of GM's monopoly began to terrify the very regulators who had enabled it. The FT had done its job too well. It hadn't just ended steam, it had effectively ended competition. By the late 1940s and early 50s, the Department of Justice began looking at General Motors with the same suspicion they once reserved for the oil barons. They saw a company that had used a national emergency to corner a critical infrastructure market. The government, having shut down the FT's production in 1942 to focus on war, now threatened to shut down EMD's dominance to save the market. They launched antitrust investigations, alleging that GM was using its massive economic leverage to force railroads into buying their locomotives. The argument was that the FT hadn't won on merit alone, but on manipulation, that the reciprocity of shipping GM cars on railroads that bought GM locomotives was the real engine behind the success. Whether that was true or not, the damage to steam was irreversible. The infrastructure of the railroad network was changing physically. Water towers were being toppled. Coaling towers, those cathedrals of the steam era, were abandoned to rot. Roundhouses, designed for the maintenance of steam engines, were being demolished or converted. The FT had forced a terraforming of the industrial landscape. Even if the government broke up EMD, steam could never return because the world it needed to survive had been dismantled, brick by brick. The tragedy of the FT is that it is often remembered merely as a first, rather than the executioner it truly was. It didn't just outperform steam, it demoralized the steam engineers. It proved that a box on wheels, devoid of the rhythmic life and breath of a steam engine, could pull more, stop faster, and run longer without rest. It turned the romance of railroading into the business of transportation. By the time the last FT was retired, the revolution it started had consumed its creator. Most FTs were not preserved. They were traded in, stripped of their trucks and prime movers, and melted down to build the GP series that would define the next generation. The Predator became the prey of progress. They were unceremoniously cut up in the scrap yards of the 1950s, their steel recycled into the very machines that would replace them. Today, looking back at the few grainy photographs of an FT set storming up Cajon Pass or fighting through the winter drifts of the Northern Pacific, we don't just see a locomotive. We see the pivot point of the 20th century. We see the moment where the analog beast died and the industrial efficiency machine was born. The government tried to pause it, the competitors tried to copy it, and the railroads tried to break it, but the FT survived just long enough to change everything. It stands as a testament to a specific kind of American brutality, the willingness to destroy a beloved 100-year-old technology instantly for the sake of efficiency. The steam engine was art, the FT was a weapon, And in the war for the rails, art never stood a chance. The smoke has cleared, the water towers are gone, and the roar of the 567 prime mover is now the only sound echoing off the canyon walls. The diesel didn't just win. It erased the past so completely that we have to dig through the rust just to remember what we lost.